Okay, so a short little video on collision theory. What is collision theory and how does it fit in with the wider scheme of chemistry? Okay, so collision theory. Collision theory is the theory that sits behind when a reaction can occur. So in order for a reaction between two particles to occur, there are three things that these particles must do. 1, 2, 3. So if I take a particle, let's just draw particle A. There we go, particle A, shade it in. And let's take particle B. And shade him in. Okay, so we've got a couple of particles here. For those two things to react, what must they do? Well, if they're travelling in opposite directions, they are never going to collide with each other. They are never going to react with each other. So that is not going to work. So let's get rid of that. What is necessary? Well, if these two things are going to react together, they have to collide with each other. So they need to hit each other. In order for a reaction between two particles to occur, the particles must collide. Which, if you think about it, you probably got a clue from the fact that this is called collision theory. Okay, now, that is not all though. There are a couple of other things that need to occur. So, I've drawn the particles as very uniform, hopefully, spheres. Not very complicated. But if we're dealing with very big, complicated molecules, if we're dealing with biochemical molecules, if we're dealing with things that are very large, then actually the collision is a little bit more complicated. For example, if you imagine that you are shaking hands with somebody, obviously your hands have to match up, join up, link up. Okay, you have to collide, in inverted commas, with the other person. There's no point you putting your hand on their shoulder and then putting their hand on your head. That's not going to be a handshake. That's not going to be a successful reaction in that sense. So what else has to happen? Well, those hands have to meet. So not only do the particles have to collide, they need to do so with the correct orientation. So, go back to that shaking hands analogy. If people are shaking hands, the two palms have to connect, and that's how the hands are shaking. You can't put the two backs of the hands together. That's not the correct orientation for a handshake. Okay, last thing. If the particles, and we'll go back to our little analogy down here, if the particles don't hit each other hard enough, they might just bounce off. So instead of these two particles ending up reacted together and stuck together, instead of reacting and sticking together, if they do not collide hard enough, they might just end up bouncing off of each other and going in other directions. This is what we want for a successful collision. This is not what we want. So they need to collide. They need to collide with the correct orientation, and they need to collide with what we call sufficient energy. Now, that sufficient energy is dependent on the exact reaction that you're dealing with, and that sufficient energy has a name. The minimum amount of that energy is called the activation energy. The activation energy. The minimum energy required for a collision to be successful. What do we mean by successful? For a reaction to have happened. So, collision theory, just a quick recap. 3 things. For a reaction to occur between 2 particles, those 2 particles must first collide. They must collide with the correct orientation, and they must do so with sufficient energy, which in terms of exam technique we would say is the activation energy. And the best way of doing this, and I'll do this in a solid pen just so for the last thing, so that we know what we're talking about. The best way to talk about activation is collide with greater than or equal to activation energy. So remember, activation energy is the minimum amount of energy required. If you hit with just the right amount of energy, the activation energy, and the correct orientation, your reaction will be successful. If you collide with way more than the activation energy, it will still be successful, which is why we talk about the collision occurring with greater than or equal to the activation energy. And the best point about this is if you carry on to do A level, that wording will serve you really well through A level as well. So I hope that has helped. I hope that has cleared things up. And read it through again, watch it through again, take your own notes, and carry on with rates of reaction and collision theory.